Hi, in this video we'll look at how to solve quadratic equations using the quadratic formula, and we'll look at how to predict the number of solutions before solving. So first let's look at a quadratic equation, or a quadratic equation. We have negative 2x squared plus 8x minus 5 is equal to 0. And then we've got the graph of its corresponding function f of x is equal to negative 2x squared plus 8x minus 5. So if I let f of x be equal to 0, and then I solve for x, well, that's going to give me 2 points on this graph. It's going to give me 2 points where the y value is equal to 0. These 2 points right here. Now, these 2 points are coordinates, but their x values correspond to the solutions to this equation. So since this quadratic function has two x-intercepts, these 2 points are called the x-intercepts, this quadratic equation is going to have two solutions. So we can say from graph of f of x, we have, or let's say we get two x-intercepts. Therefore, there will be two solutions to our equation. So there should be two solutions to this equation. Now let's look at what the solutions actually are, because I mean, just from the graph I can't really tell immediately where exactly the x-intercepts are. But if they were integer values, then I could get the solutions to this equation exactly just by looking at the graph. So let's go ahead and we'll solve this using the quadratic formula. The quadratic formula says that x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Let's plug in the values for a, b, and c. Well, b is 8, so I get negative 8 plus or minus the square root of 8 squared minus 4 times a, which is negative 2, times c, which is negative 5. So I have to take the square root of all that. All divided by 2a, which is, let me write that a little bit nicer. All divided by 2a, which is negative 2. So we have all over 2 times negative 2. Now we can go ahead and evaluate this. We've got negative 8 plus or minus the square root of, well, let's see, 8 squared is 64. So we get 8 squared minus 4 times negative 2 times negative 5, which is this root 24. So negative 8 plus or minus root 24, all over negative 4. Now, I know that I can take the square. I can't take the square root of 24 because 24 is not an exact value. So I'll just reduce this radical. So I get negative 8 plus or minus the 24 factors to, or 24 is divisible by 4. So this reduces to negative 8 plus or minus 2 root 6, all over negative 4. Now, the numerator and denominator are both divisible by 2. So I can write this, to simplify this, I can write this as 2 bracket times negative 4 plus or minus the square root of 6, all divided by 4. Now, 4 and 2 are both divisible by 2, so I can divide out a factor of 2. 2 divided by 2 is 1. 4 divided by 2 is just 2. So my two roots are x is equal to negative 4 plus root 6 over 2. And my other root is x is equal to negative 4 minus root 6 over 2. So as predicted, I get two roots for this quadratic function, or for this quadratic equation. Now let's look at another interesting thing. Well, notice that the value of b squared minus 4ac was 24. So we had that b squared minus 4ac was equal to 24. And so we can say that b squared minus 4ac in this case was greater than 0. And when b squared minus 4ac was greater than 0 in this case, I got two roots for my quadratic equation. So that's something to keep note of. And if you look, if b squared minus 4ac is greater than 0, you'll always get two roots, because if you look at how the quadratic formula is set up, well, you'll get one value of negative b plus the square root of this number here, and you'll get another root where you'll have negative b minus the square root of this number underneath the radical. So anytime that b squared minus 4ac is greater than 0, you'll always get exactly you'll get two distinct roots. You'll get two different roots to your quadratic equation. That concludes this video.